Good. Yep.
Good. You are my last student, I think. You're the last one that still has a final to go.
So for the finals, huh? That's great.
Yeah, everybody, most of them had it today. But,
Not my first.
yeah, I have a couple that whose last final is tomorrow. But then I'll have lots of time off. All right, let's see. I think we left off on this statistics stuff, didn't we?
Yeah, and actually, I think that do you think that we can skip this?
Yeah, we can skip that. I'm pretty good.
We can skip the 20, and what about this one?
21 is really easy.
21 is possible. So what we were going to do, David, was to skip the statistics stuff. We think he's got that down pretty well.
Okay.
So maybe what we could do is, basically what his teacher said is that like everybody else, I suppose, is that the contents of the exam are on the this sheet that he passed out here. So I guess that one of the things that he just wanted to do is maybe if you could pick, looking at the first page and the top of that second page, maybe if you could pick some similar types of problems. And, what we really want to focus on is making sure that he has the big rules, on the big subject matters that he's going to be dealt with. So, if that's a way to approach it or if you have a better idea or what.
No, that's fine with me. If he wants to, in other words, I'm not totally sure where his strengths and weaknesses are on this page, but I can certainly give him similar type problems. I can make.
Yeah, hold on just for a second then, David. You have, Patrick, like when you look at something like this, you say, like, these are the ones, geez, I really am a little bit more shaky on or less shaky on. We at least start with those.
Simplifying radicals is a fairly large ability to have. So,
all right, well then, David, why don't we start? Because he can't really pick one out for me. So
okay.
Why don't you go ahead and start? I'm just going to grab.
Yeah, I have a bit of an idea just from the first time through on these, where he's weak and where he's strong. So Patrick, how would I do the square root of 80? How would I simplify that?
When we're just sort of getting them set up here just a little bit, so. All right, here, Pat, just take one of these, whatever you want. So anyway, what we basically want to do is go ahead and write down, if you would write down your problem, then you could sort of work through it step by step. All right, David, he's getting set up, so hold on for a sec.
Okay.
And I think that's the best way to handle it, don't you? Okay, so what would you be? What would you do the first step on the square root of 80?
You could break it down to 20 by 4.
Okay, let's do that. Which one should I put first?
Would you put the 4?
Good, because what's that going to turn into?
Square root of 80.
Well, no. In other words, I can take a 2 out.
Oh, yeah.
The whole goal here is to break it down by pulling out numbers. Okay. Now, is square root of 20 simplified?
Yes.
Well, how about...
Well, you could do 4 by 5.
Exactly. Okay. In other words, you're always searching for divisibility by one of your perfect square numbers. Give me the list of perfect square numbers starting at 4.
There's
Count up from 4. In other words, 2 squared is 4. 3 squared is
9.
Next one.
16.
Keep going.
25.
Keep going.
36.
Keep going.
49.
All right, that's generally far enough. So, in other words, if we can divide these numbers by any of these numbers over here, we need to do so. So, how can I simplify this further?
You could, the 2 or the 20?
Both. In other words, I can't do anything with the 2 yet, but I know I can do something with the square root of 20.
Well, the square root of 20 would be 4 by 5.
Okay, it's important that you understand that it's the square root of 4 times the square root of 5. In other words, this is what you've done, is turn the square root of 20 into square root of 4 times square root of 5. And that's good. You can do that. So what's the next line going to be?
Would be 2 4 square root of 5? Or
Well, what's the square root of 4? The reason we broke it up into the square root of 4 times the square root of 5 is that one of those is equal to a whole number.
Oh, the square root of 4 is 2.
Okay, so what's the final answer?
Would it be 4 square root of 5?
You got it. In other words, you keep multiplying these numbers together if they become real numbers. When I pull that 2 out, I still have to multiply it by that 2. Okay, let me give you one more of these. And it doesn't really matter if they put a 2 under here or they multiply it by a 3. None of that matters. The difficulty is in simplifying that. So, how about this one?
See, this is why I brought you this chart right here.
What you really need to be good at here is division. You need to be able to quickly divide this number by 4, by 9, by 16, by 36, any of those totals. If you can divide it by any of those numbers, then you can simplify it.
Alright, so that would be 2 by 36.
Okay, so tell me exactly how to write it.
It would be square root 2 square root of 36.
Okay, times square root of 36. And now what does that become?
That would become this 36 would become the square root of 6 by 6.
So what's the answer?
Would be 2 square root 36.
Square root of 36 turns into a whole number.
This doesn't stand out. Focus. You find your whole numbers.
This is 6 squared. So what's the square root of 36?
Hold on for a second, David. I gotta get rid of this.
Patrick, what's the square root of 36?
It's 6.
Okay, so what's the answer?
Would be 2 square root 6.
You got it backwards. It's not 2 square root of 6.
Oh, it's 6 square root.
There you go. In other words, the square root of 2 doesn't change, so I got to leave that the same. But this becomes 6, and I can put it in front instead of after. Okay? It doesn't matter the order. In other words, square root of 2 times 6 is the same as 6 times square root of 2. All right, so about square root of 8. Just a tip, put the perfect square number first, not second. In other words, last time when we had square root of 72, you put it square root of 2, square root of 36. You'd have been better off if you'd have switched them around. This is the perfect square number right there. Okay? So kind of get in a habit of doing that when you're simplifying these. What's the perfect square number that divides into that?
4.
So I'm going to put that first. What's the other part of it?
M square root 2.
And what's that equal?
That would be 2 square root 2.
Uh-huh.
Yeah, see, that way when this drops off.
That's exactly how you want to do those.
And you've got your square root there. So it's set up as a formula, so you can't miss it.
All right. I think we probably should go on. Let me give you one of these. Give me the next line, or tell me what you would do, and then read the next line.
You could do 3x squared equals 15. I mean 25.
Okay. Is this going to be a calculator test or a non-calculator, or a little bit of both?
It's going to be completely calculator.
Okay. You have a calculator in front of you?
Well, yeah.
Get one, and let's get you used to using it. In other words, if you're going to be able to use a calculator, then you don't want to rely on your memory or your, because it's not 25.
Right, he's panicking. I don't know why he's not concentrating.
Well, that's okay. I want to get him to where he's going to be under the same conditions as he's going to be tomorrow. If that's a calculator, then let him use the calculator. What's 36 minus 9?
You need to write. What you need to do really is write it out. See, the less that you do in your head, the more apt that you are that you're going to get it right, Patrick. When you try to do things in your head, you just don't get them right.
Okay, it's 27.
Plus, you need to show your work. This lady makes you show all your work. So you need to show 36. Yes, it does. It says on the paper, Patrick. Well, we can talk about this later. But you should have on there 36 minus 9. Okay, so she can see what you're doing. Okay. Then you'll have a better chance. All right, go ahead.
What you're talking about is doing that.
Right, and that's what the teacher wants him to show.
I agree. I agree. If you're not perfect at it, you need to put it down there like that always.
You're less apt to make a mistake if he writes it down. When he tries to do it in his head when you're on
For sure. Always only do one step at a time. Don't do multiple steps at the same time. So now we got 3x squared equals 27. What's the next step?
You could divide each side by 3.
Okay, what's this going to be equal to? Next line.
You write it out. X squared equals...
Use your calculator.
9. It'd be 9.
Okay. And finally, what's the answer? Well, let's write it out. How do we solve this? X squared equal 9.
Well, it'd be x would equal 3.
You take the square root of both sides, right?
Yeah.
Okay, so I'm going to take the square root of that side. I'm going to take the square root of that side. Square root of x squared is x. Square root of 9 is not 3, it's what? What should you begin every answer with when you've taken the square root of both sides of an equation?
Plus or minus.
That's correct. Notice that minus 3 times minus 3 is equal to plus 9. So the minus solution is every bit as important as the plus solution. And you will definitely lose points if you only put that. So remembering that plus or minus is huge. That's going to be half credit on these problems. Okay?
Hey, Rob.
Okay.
Could you give me a favor?
Okay.
Yeah.
All right, let's talk about translations. You're actually pretty good at most of these translations. Let me give you a different one.
Yeah, the water's hot.
What's the elementary function that this is a translation of?
Wouldn't that be y equals x squared?
Oh, good. So what's happening to it? There's 3 things. Name.
Well, you have you have a vertical stretch of 3, horizontal shift right of 2, and then a vertical shift down 7.
All right. I don't think we need to go over those. You're good at these.
So that was what? That's like number 3 pattern. Question 3. Sorry.
There is the question of graphing it. So tell me how to graph the elementary function, y equal x squared. Because I know you know the translation, so I know you'll know how to move it relative to the one I gave you there. But what does this look like? I know that's hard to describe verbally. Where's the vertex? Now, what is it, first of all? Is it a straight line? Is it a circle? Is it, what's it called?
It's a parabola.
Okay, is it open up or down?
When it open up.
Okay, so it's going to look something like that, right?
So would the vertex be at negative 4, 2?
Well, on this one it would be, yes. On this, the one I gave you, where's the vertex?
Would it be at 0, 0?
And we know it goes up, so it really only has one way to look, like that. Okay? So, if you know the elementary function, then transformations are a piece of cake for you. You know what transformations. You said it vertically stretches by a factor of 3, which makes this parabola skinnier. Okay? And this is the one I made up. You said it horizontally shifts by 2 units to the right. So we would go there, and it would look like that. And then finally, it's down by 7. Just find the key point, which is the vertex, and move it. That's the only point you really need to worry about. And so that's what the final thing is going to look like. All right.
And David, on that same area, is there a set equation for calculating the axis of symmetry?
Yes, there actually is.
Basically just the middle of the parabola.
Well, it kind of depends on the form you're given it. In other words, if they give it to you in this form, this is in vertex form. So you know the vertex is at -4 plus 2, and the axis of symmetry is the x-coordinate of the vertex. In other words, the axis of symmetry when it's in this form is x equal -4. Okay? So if it's in vertex form, the axis of symmetry really is a piece of cake. Where it's not necessarily so easy is when it's in standard format. This would be standard format. Now, you don't know where the vertex is because it's not in vertex format. But there is a formula for the line of symmetry. Do you know what it is? The same as the x-coordinate of the vertex. And it's the first half of the quadratic formula.
Right. Okay.
By first half, I mean that visually. You remember what the first half of the quadratic is?
You got that cheat sheet.
So would that be 2x squared -4?
No, it's minus b over 2a.
The quadratic formula.
Right. Look at the quadratic formula and see if you know what I mean by the first half.
Yeah, I see that.
Okay.
Because the other one is the determinant.
Yeah, the discriminant.
Discriminant.
Right.
Sorry.
In other words, the rest of the quadratic formula, there's not really that much more to it. It's plus or minus the square root of the discriminant. What's the discriminant?
It's b squared -4ac.
There's your whole quadratic formula. So this first half, what I call the first half, is the x-coordinate of the vertex. Well, let's figure out what that is. In the quadratic I wrote here, 2x squared minus 4x minus 9, what is the x-coordinate of the vertex?
Would it be 1?
Okay, so minus b is positive 4
Over
4.
positive
Okay, so what's the line of symmetry that your dad talked about?
Would it be 1?
It's x equal 1.
X equal.
Because it's got to be an equation. Right?
Yes, it has to be an equation of a line, because this parabola is going to be, I don't know, somewhere like that, and the equation of that dotted line that represents the line of symmetry is the x-coordinate, notice, of that vertex. So once you find the x-coordinate of the vertex, then the equation of the line of symmetry is easy. It's just x equals that number. How would I find the y-coordinate of that vertex?
Would you plug in 1?
Tell me what it is. In other words, tell me what it is showing your work. The y-coordinate.
2x squared, that'd be 4.
Hold on. What was the x-coordinate?
Oh.
Okay, let me show you how you want to do this. You want to write it like this. You don't want to do it in your head. Just do a direct substitution like that, and then go on to the next step. Okay, in other words, once you get it substituted, now you can simplify it. Well, what's this?
That's 4.
What's 1 squared? What's 1 times 1?
Oh, it's 1. So that'd be 2.
Okay.
I thought it was like 2.
That's all right.
I thought it was taking 2 and squaring that. That would be minus 4. And minus 9.
Okay, what's that answer? Make sure you can do this on a calculator. I don't mean that you can't do it in your head, but I want to make sure you can do 3 digits with 2 subtractions taking place on a calculator.
Well, why don't you just run that then? See, because we've got what is it? 2 minus 4 minus 9 on the calculator. Because we got time tonight. We don't need to rush through this. These are sort of cleanup issues. You know, David, while he's negative 11.
Good.
While he's doing that, he had a question on that. Y equals 2 times parents 1 squared.
Mm-hmm.
He said, well, I thought you go ahead and multiply the 2 times 1 first and square it. Is that another, just a rule of
Here's
hand?
the rule. Here's the rule. The rule is when you have an exponent, it only operates on immediately what it's above or what it's above in parentheses.
Okay.
So the square does not operate on this 2.
Gotcha.
It only operates on the 1, and in fact, I could have written it like this. 2 times 1 squared. The only reason I put parentheses around it was for clarification. In other words, it's a little more understandable if you put parentheses around it. And in the context of the problem, what we're doing is we're substituting for x. In other words, whatever we solved, the x-coordinate of the vertex is, we're substituting it. So that's the other reason I used parentheses. Notice that in the original formula, the 2 does not operate on this 2. It only operates on the x.
Is there a formula?
All right. Let's do some factoring. Because factoring, I'm going to make up a different one here. Hold on. Let me think for a moment. Hold on. Let me put my dog out of the room. Guy, come here. Come on. Come on. All right. not sure whether I should teach you my method of factoring or let you go with the method you've learned. There's lots of different ways to factor. So I don't really want to confuse you. If you've learned the California method, the proof of the pudding is your ability to factor these. So you know how to factor this without using your calculator? They may let you use your calculator for arithmetic, but they're not going to let you factor stuff with it.
Yeah, I know how to factor that.
Okay, what is it?
Let me just do it out. So it would be X. Oh.
Is it 1 times 10? 1 plus 10?
Oh, yeah. It'd be X plus 1 and X plus 10.
Okay, good. So let me give you some more factoring problems, because factoring is the tough.
Try to go that way as best you can. And remember what David told you the other night about making a chart. Remember on the factoring chart he had that you start off, and if you do half, then double, half, then double. That will at least get you going. If you mind block.
Okay, give me factors of 10.
10 and 1, 5 and 2.
Is that it?
And that's it.
Okay.
That's it.
So
that one has to be -5 and -2.
okay, let me give you a key on factoring. Start out your factoring by looking at the sign on the constant term. Okay, that's the most important thing to start with. That tells you what your signs are going to be on both of these terms. What do they have to be to get a negative sign on the constant?
Do they have to be both negative?
They have to be opposite. That's what they have to be. You only get a negative sign if you're multiplying a negative times a positive. If you're multiplying two negatives together, you get a positive. If you're multiplying two positives together, you get a positive. So the fact that we're looking at a -10 means that one of these has to be plus, one of them has to be minus. That's the way where you should start. Okay? Now, in other words, we've got 2/3 of it done, right? So the last step on these simple factoring problems is what? We're looking for factors of 10 that do what? Subtract or add?
That don't they have to times into?
Again, look at this.
So
they need to subtract to the number 3. You don't care about the sign yet over here. We're doing this step by step. We merely need factors of 10 that subtract to the number 3 because there's a negative sign there. That's why they have to subtract. And there's a 3 there. So what two factors subtract to 3?
5 and 2.
Take the biggest of those factors, the 5, and put it with the sign that's in the middle right there. So the 5 goes here. The 2 goes there.
Okay.
David, when you said for him to focus on the sign of the consonant, that's obviously the last single number without a letter with it,
yes.
Right?
In other words, you have a quadratic, you have an x squared term, you have an x term, and you have a constant term. Notice that once I've factored it, if I were to multiply these back together again using either FOIL or ET, the very last step is going to be multiplying this plus 2 times this minus 5. And that's what gives me that minus 10. And it could be a minus times a plus, but the signs have to be opposite whenever that's a negative. Factor that. I kind of like you to look at these as 3 or 4 step processes. The first step, you break up this term into what?
X and X.
Okay. Second step, you figure out what your signs are. What are your signs?
Would they be opposites?
Correct. And it doesn't matter if I go plus, minus, or the reverse. They're the same. They're going to end up being the same thing. As long as the coefficient of this is 1, they're going to be the same thing. Once we get into these kind of quadratics, it's a different story. These are much harder. But let's make sure you can solve the first level quadratics. If you can get good at these first level, that's going to take care of 80% of the problems you're going to have to factor. And I'm not kidding. By a first level quadratic, I mean where the coefficient of the x squared is a 1, which means you can always break it up into x and x. And then you go from there. It's much simpler if it's x and x. Okay? So now, what am I looking for as I've done the first 2 steps? The third step would be what? Factors of what that do what?
Factors of 10 that add to 9, which would be 10 and 9.
Not add. That's still a minus sign.
But subtract.
There you go. To 9.
Yeah, so it'd be 10 and negative 1.
Okay, which one goes where?
The 10 goes first, the negative 1 comes second.
No, the 10 goes, the bigger of the factors has to go with the sign of the middle.
All right.
Okay? Always. So the 10 is the bigger of the factor, it's got to go with the plus sign. The 1 has to go there. Why? Because you get this term by multiplying the insides and the outsides. Notice that in order to get a plus sign here, I've got to have the bigger number with the plus sign. So that's why I always put my bigger factor with the sign of the middle term. Because when I multiply the insides, I get minus 1x. When I multiply the outsides, I get plus 10x. Well, add those two together, you get plus 9x. That means we factored it correctly. I don't really need to check anything else. I only need to check the middle term, because the way I did the factoring, I know this term is correct, and I know this term is correct. The only term that I'm not 100% sure of initially is the middle term. So this little double smiley face thing is always a good check to do, to make sure you got the middle term correct. Factor 80 for me.
Well, you could put 4 times 20.
Start. In other words, I want you to give me all the factors.
See, that's what you said about starting a list.
Start there.
Well, you could have 80 and 1.
Okay.
You could have 40 and 2.
Okay.
You could have 20 and 4.
Good.
You could have 10 and 8.
Good.
You could have 5 and 16.
Aha. There's the one most people don't see. They don't realize that 16 is a factor of 80. That's important because 16 is a perfect square number. Now, do we have all the factors?
Yeah.
I think we do. We could triple 5, but we can't third 16. So, in other words, it's not always doubling and halving. If we take another one, Factor the number 75. Start with that. Now you can't take half of 75, but what can you do? Think in terms of, can you take a third of it? Can you take a fifth of it? Can you take a sixth of it?
You can take a third of
What is it?
the 37 and...
What's a third of 75? Get your calculator, divide it by 3.
3 and 25.
All right. So I take a third of 75, I triple to 1. Now what? I still can't take half or double. What can I do with 25? In other words, you always want to look at the biggest number left as to whether you can break that down. 25 is not prime. It's divisible by something. What's it divisible by?
5.
Okay, so I want to take a fifth of it. When I take a fifth of it, I get 5, which means I got to do what to the 3?
Would you times it by 5?
Okay, which makes it 15. So there's another set of factors of 75. 5 times 15. Now, don't think I can do anything more with 75. In other words, I could take a third of 15, turn it into 5, but then I got to take 3 times 5, so those aren't two different factors. In other words, it doesn't do any good unless you find different factors. All right. Let me think for a moment whether I want to give you one more factoring problem. Let's do at least one of the higher degrees of difficulty. Let me think for a second. I want to change it up a little bit. Let's make it a negative sign there. And let me think. Make this minus 9. All right. This is harder just because it's 2x squared, not x squared, which means I can't immediately say x and x. What can I immediately say?
X and 2x, or 2x and x.
Okay, either one is fine, doesn't matter. What's the next step?
You find the multiples of negative.
Hold on. The second step is always determine the signs.
So since they're both negative, would they be opposite?
Since this is a negative 5, they would be opposite. Because you cannot produce a negative 5 unless these signs are opposite. The thing is that plus minus is not the same as minus plus now. Because notice, whatever number I'm putting there has to multiply this. Whatever number I'm putting over here is multiplying 2x. So that's why this is a harder problem. The signs are opposite, but they might be plus minus or minus plus. So I kind of have to allow for both of them. And that's just the way I do it. I allow for both by writing it like this. Okay, what are factors of 5?
You do 5 and 1.
That's it. So that takes away a lot of the decision. Now I got 4 choices. I can do 5, 1. I can do 1, 5. I can do 5, 1, or I can do 1, 5. And this is now a trial and error problem. In other words, we only have 2 factors of 5, so it's not like there's 100 different possibilities. It's one of the 4 that I just laid out. Which one you start with, I don't think it really matters. I'm going to start with this one. Does that produce the proper middle term? Or if not, what does it produce as a middle term?
It produces a positive 9.
Produces positive 3x. In other words, if I add those two together, multiply them, excuse me, that's plus 5x. And if I multiply minus 1 times 2x, then I got minus 2x there. Add those two together, you get 3x. Unfortunately, when you're doing trial and error, you got to do a lot of this kind of stuff, a lot of these real tiny multiplications, just to see how it factors. Okay? Now, so that doesn't work. That does not give me a minus 9x. Okay? Let me try switching. Just for effect, I'm going to try the 5 there and the 1 there. I want you to see what happens when I do it this way. In other words, I'm randomly trying this. I'm not figuring anything out. I'm just randomly trying one of my 4 possibilities. Does this work?
No.
What number does it give you? It's not just whether it works or not, it's what number does it give you in the middle.
Would it be 4x?
Minus 1x, what's plus 5 times 2x?
Oh, I see. I see what that's saying. So that would be positive 9.
Aha, that's key. We got the right number, the wrong sign. When you get the right number, wrong sign, is all you have to do is move your numbers to the other sign. In other words, this 1 needs to go with the plus, this 5 needs to go with the minus. The fact that I got the right number, wrong sign, guarantees that this is going to be correct. You see why it's minus 9x now?
Yes.
Okay. Well, let's go back to my trial and error. Remember, my first thing I tried was 5 and 1, right? Just randomly.
Yeah.
Well, that didn't give me the right number or the right sign, which means there's no reason to try the 5 down here and the 1 down there, as all that's going to do is change the sign on the answer. So I know I don't have to try 5 and 1 down here. I'm going to try this possibility. That gives me the right sign and the right number. In other words, by figuring out your first trial, what number it gave you, it eliminates half of the remaining things you have to try. So it narrows down to the correct answer much quicker. All right. When you have a situation like this, where it's not x and x, it's 2x and x, you can't use any of those rules. I can't say factors of 5 that subtract to 9 or add to 9. I can't do that. I can only do that if it's x and x. In other words, I can't make any statement at all other than I need factors of 5. Okay, and the signs have to be opposite. I know that much, but I can't make any statement about what they have to do. Because notice one of these factors multiplies 2x and the other factor multiplies just x. So that changes the condition significantly. All right, let's go on to completing the square. Complete the square of this for me. What do I have to do?
So you take the half of the 10x and then
Not half of 10x, half of 10.
Half of
This is the coefficient, not the x part.
So half of 10 and then square that.
So what do I need to write over here?
25.
Plus 25. I can't just write 25. In other words, notice that if I just write 25 there, it doesn't mean anything. That you cannot assume a plus sign when it's part of an expression. If it's part of an expression, I need to put that plus sign right there. Now, how can I write that quadratic? The reason I completed the square was so I'd be able to write it as a linear term squared. That's what they mean by a perfect square trinomial. What would it be?
Would it be x plus 5?
Quantity squared. Notice that if you FOIL this out, or ET it out, you get x squared plus 5x plus another 5x plus 25, which is x squared plus 10x plus 25. Okay, now make one change. Now complete the square.
Wouldn't it still be 25?
Is it still plus?
Yeah, it's still plus because negative 5 squared is negative 5 times negative 5.
Good. I was trying to trick you. What's that gonna, how can I represent that as a linear factor?
Would it be x minus 5 squared?
Right. In other words, this sign depends on that sign. If the middle sign is negative, this is always going to be negative. If the middle sign is positive, this is always going to be positive. And it's x minus 5 quantity squared. Okay. So you feel you're good on completing the square?
Yeah.
I think so too.
What about that number 5, David, just so he understands a perfect square trinomial?
That's what we just did.
Okay, actually, I thought that we did number 6, that completing the square.
Well, number 5 is actually a completing the square problem.
Oh, I understand. I see it, yeah.
Okay? Even though it doesn't say that, that's what you have to do. To come up with this number, you have to complete the square. And then
one of the other things that we sort of had for his little cheat sheet, David, is what is the difference between radical notation form and rational notation form?
Okay. This is radical notation. Let me write square root of 2. The other way I can write that is as a decimal that has been approximated.
Okay.
Okay. So this would be radical, this would be irrational. A radical doesn't always mean irrational, but most of the time it does. Unless it's, say, radical 4, then that's not irrational. It's a real number. It's a rational number. So rational has to do with whether a number can be written as a fraction or not. Okay, I can write 4 as, or the square root of 4 as 2 over 1. I can write that as a fraction. That makes it a rational number. I cannot write the square root of 2 as a fraction. It's impossible, because this thing goes on with different digits never repeating forever, which almost all radical numbers do. In other words, square root of 3 is irrational, square root of 5 is irrational. If it does not turn into a perfect number, then it's irrational.
Right. And that was good because, you know, Patrick actually explained that to me. So I think he's got that one down too. So that makes it good. So we got the open up, simplify. He's got that. Now on these, I guess the numbers chopped off, but I guess it would be number 10, which is the motion problem, where it says graph the function, label the key features. Is there actually an equation on those motion problems or not?
I'm not sure what 10 you're looking at.
It's the one about the soccer ball. You know, I don't know whether your question got chopped off too. But I was just wondering, it says, that's the one, graph the function, label the key functions.
It's 9.
Oh, sorry, it's 9.
Okay, I got you. Okay, graph the function and label the key features. All right. Let me write the function.
Yeah, and we went over that at the beginning. So on those types of problems, that is all the information that you need to solve the problem is provided in that what you just wrote down, right?
Yes. Now
Okay.
let's go through finding the x-intercepts, the y-intercepts, the vertex, the title, the labels, and the scales.
Yep, he did all that. Now, what about 19?
You want to review this, or is he good with this? I think this is worth reviewing.
We did this, David, when we started
I
off.
can change the numbers.
You know what? He wants to go over it one more time.
Okay. Although this happens to be a physics equation, so the numbers are almost always these numbers, but I'm going to change them anyway. All right. So let's say that's our equation.
You have those down.
How do I get the x-intercepts?
You don't you have to find the vertex first?
Actually not. The x-intercepts mean what about y?
It means it's 0, so x would be 0 as well.
No. Excuse me. It says x-intercepts. It doesn't mean x-intercepts. It means the t-intercepts. Because our curve, there's our graph. What's the horizontal axis going to be labeled?
It's going to be x.
Actually, t. The vertical axis is y. Okay? So that's for starters. But to find the horizontal intercepts, in other words, this curve's going to look something like this. It's an upside down parabola because of the negative sign there. What they want is this point and this point. So how are we going to find those 2 points?
You can plug in the x.
Well, what's our process? Find those 2 points on this function. What's your starting place?
Yeah, the y-intercept.
No, x-intercept. The y-intercept is easy. In other words, the y-intercept is where I let t equal 0. Well, what's the y-intercept if you let t equal 0?
0.
Right. So that's the easy one. The harder one is to find the horizontal intercepts, the 2 points that I've circled. To do that, you had the answer. You said it earlier. You let y equal 0. But that's not all of it. You have to be able to solve it from there. In other words, how do you solve that equation now for t? It's a quadratic, so I'm going to get 2 solutions. That's what I'm looking for. This number here and this number over there. But it's not obvious on how you solve this, so
Why don't you plug in
is there a greatest common factor? It's a factoring problem, is what it is. Whenever you see a quadratic equal to 0, it's almost always a factoring problem. Why? Because when you can get 2 things multiplied together that equal 0, you can solve them. If you have the addition of 2 things equal to 0, I can't solve it from that. If I say a plus b equals 0, there's no solution for that. Right? But if I can turn it into the product of 2 things, then I can solve it. So how do I turn it into the product? You got to factor something out of there. What's the greatest common factor?
would be 32.
Well, 16 is actually a factor of 64. 4 times 16 is 64. So I can factor the entire 16 out. But what else? I can factor a variable out also. What's the greatest common factor? That's something you definitely need to be able to figure out, a greatest common factor.
Is it t?
Well, it's minus 16t. Notice that minus 16t will divide evenly into that term, and it will divide evenly into that term. That's what you need for something to be a greatest common factor. And we'll work on some more greatest common factors after we do this, because that's a skill you definitely need. Okay, so I'm factoring out minus 16t. What goes here?
Would be
No. Here's what you do. You take this term and you divide it by what you factored out. So what's minus 16t squared divided by minus 16t?
would be just t.
Yeah, so that's what goes there. That's how you get that number. And now do the same thing. Divide that by minus 16t.
Yeah, do your thing.
Use your calculator. Divide 64 by negative 16. What do you get?
Would it be negative 4?
Yeah, and then the t divided by the t is just 1, so it's just 4. Okay, now I've got the product of two things. And you should kind of always check to make sure that you've done it properly. Multiply these two things back together. When you multiply this times this, you get minus 16t squared. When you multiply this times that, you get plus 64t. So we did it right. Now that we have the product of two things equals 0, what are the two solutions?
Would it be negative 16 and 4?
What makes this 0? That's the way you solve these. When I've got the product of two things equals 0, I'm going to set both of them equal to 0 and solve for them.
Alright, so it'd be 16 and 4.
If I make 16t, if I make t 16, does this equal 0? Remember one key rule. If you're multiplying two things together, and here I'm multiplying minus 16 times t, and I'm saying that has to equal 0, so I'm saying minus 16t equals 0. How can that be equal to 0? What has to be true? T has to be 0. The only way minus 16t can be equal to 0 is if t is equal to 0. Notice on this drawing, one of my intercepts is right there at t equals 0. So it not only fits the drawing, but more importantly, it fits this.
So
I've got A times B equals 0. That means either A is 0 or B is 0 or both. So I set A equal to 0, which gives me a solution of t equals 0. What's the other solution?
What do we 4?
Yeah. In other words, I'm going to say, well, t minus 4 has to be equal to 0 also, which means t equals 4. And on my curve, that's this point right there. All right, let me do some more greatest common factoring here. Factor that.
Would it be...
Now notice one thing here. There's no constant, right? In other words, it's an x squared with a coefficient, and it's an x with a coefficient, which means I can always factor at least an x out. If I add a constant in there, well, now I can't do that. In other words, now I have to factor it like we factor. But if there's not a constant, you can always factor out at least an x. What else can you factor out besides an x?
You can factor out 5.
Okay, so 5x is the greatest common factor. What goes here?
Would it be 5x?
Remember that whatever I write there, I'm circling. Those aren't zeros. There's going to be two things. Start by taking that and divide it by 5x. What do you get here?
What'd you get on 2?
Well, what's 10x squared divided by 5x?
Would that be 2x?
Right. It's 2x. And now divide 5 minus 5x by 5x. What do you get?
Would be -1?
Right. So that's how you do greatest common factor. You just figure out what it is and then divide each term by it. And when you're taking greatest common factor, you usually end up with a monomial term times a binomial term. I'll give you one more. Factor this. And it's a greatest common factor problem because I can immediately see that I can take an x out. Can I take more than an x out?
You could take 3x.
What's left over?
It would be 3x to the second? I mean,
Do it as a division problem. Rather than just guessing or trying to do it in your head, write down on a piece of paper, okay, I need to take 3x cubed and I need to divide it by 3x. What does that give me?
1x to the second?
Right. X squared. That's what goes there. And after I've done it, mentally, I'm going to multiply this back together. Do I still get 3x cubed? Yes, I do. So I'm in good shape at this point. What's the second part? How do I get it?
Wouldn't you take a
Minus 6x and divide it by 3x. And what does that give you?
It'd be -2.
And that's all I need to do. It's that straightforward. And then mentally, I'm going to multiply that by -2 to make sure I get -6x. I do. I've done it correctly. Now, if this happened to be an equation where this whole thing was equal to 0, now I can say that's equal to 0. And now I have the product of two things equal to 0. What's the solution now?
I'll go get the dog.
I'm going to give you a hint. There's 3 solutions, which you would expect because we started out with a cubic. Quadratics give you 2 solutions. Cubics give you 3. Quartics give you 4. So what's one solution?
I'm sorry, I was a bit distracted by the dog's arm. What'd you say?
Okay. What are our 2 solutions? If I've got 3x times this quantity equals 0, how do I solve it, the rest of it?
Wouldn't you just use ET by
No, we're not multiplying. We started out with it having been multiplied. In other words, it was multiplied together when we got it. We're separating it into 2 things. The reason being is that we know that if I have 2 things multiplied together and they equal 0, then either of those things can be equal to 0. So set both of them equal to 0 and let's solve for it. So let's set 3x equal to 0. That's one of the things. What does x have to be?
0.
Okay, that's one solution. Next thing, let's set x squared minus 2 equal to 0.
So that would have to
Be
be
careful. What's the first step?
set x to 0.
Well, no, what's the first step in solving this? If I gave you that as an equation, how do you solve it?
You could add 2.
Good. So now I got x squared equal 2, and this is where you need to be careful. How do you solve that?
You root both sides.
Good. So what's the answer?
X equals 1.
No. Square root of 2. In other words, if I root both sides, that's what I'm doing. The square root of 2 is not 1. The square root of 2 is the square root of 2. Okay, but I left something off.
The plus.
Right. So it's plus or minus 2. Now notice we have three solutions. We have x equals 0, x equal plus root 2, and x equal minus root 2. We would expect to have three solutions because we started with a cubic function. So you should be looking for three solutions. If you only came up with two solutions, you most likely have made a mistake. Not necessarily, because you can have only two solutions. But most of these problems, you're always going to have the same number of solutions as the degree of the expression. This was a cubic. We would expect three solutions. And that's helpful because if I did make a mistake and leave off my plus or minus, now I'm looking at only two solutions. That's a flag. That's a red flag. It tells me I probably did something wrong because I've only got two solutions and I started with a cubic. What did I do wrong? I left off my plus or minus. There's my third solution. Okay. Like I said, the y-intercepts are very straightforward. You just set the other variable, in this case t, to 0. And usually when you set t to 0, here, let me give you another equation here. What's the y-intercept on that right there?
7.
Yeah. That's the way you do y-intercepts. Is you plug in 0 for x, and it makes that term go away, that term go away, and the only thing you have left is the constant. So y-intercepts are particularly easy. X-intercepts are the toughie, because you have to set y equal to 0, and now solve that, and that's not that easy to solve. I mean, it can be, but that's the difficulty usually, is solving that quadratic. And of course, the first thing we would try to do would be to factor it. If it's not factorable, we have to use the quadratic formula. What's the quadratic? Oh, that's on your cheat sheet. You don't need to memorize that. This table here, that's very useful if you have no clue as to how to graph it. Let's say that, wow, I'm looking at this function and I don't have any clue as to what that is. I mean, we know it's a parabola, but let's say you didn't. Well, all you have to do is come up with a couple of points, and that lets you draw dots on this graph, and then you connect the dots. So if I come up with a t of 0, I get y of 0. If I come up with a t of 1, I get y of minus 16. And if I come up with a t of 2, I get y of 0 again. Well, let's just graph those 3 points. When t is 0, y is 0. That point's on there. When t is 1, y is way down here, minus 16. And when t is 2, y is back to 0 again. Well, there's 3 dots. If I draw a curve between those 3 dots, if I have any idea that it looks kind of like a parabola, then there's my graph. And I only needed 3 points to get it. So that's their point in putting this here, is that this allows you to graph any function. It doesn't matter how complicated it is. You can put 3 or 4 dots on the curve and just connect the dots. Now, let's go back to this problem. How would we get the vertex? Because that's the one thing we didn't do. We might have done it the first time through.
Negative b over 2.
What is it?
Negative b over 2a.
Good. That's the x-coordinate of the vertex, but that's a good start. I like to write that like that as opposed to the y-coordinate of the vertex. Okay, so it's negative b over 2a. That needs to be on your cheat sheet, your note card, whatever. And what's that equal to for this equation here?
Negative 32 over 2 negative 16.
Which is 2 times negative 16. Okay. What's that number equal to? What's negative 32 divided by 2 times negative 16?
Oh, the 1.
Okay. So that gives me the x-coordinate of the vertex, also gives me the line of symmetry. That means x equal 1 is the line of symmetry. How do I get the y-coordinate of the vertex?
Wouldn't you just plug in t?
Plug in
Or
1 for t.
0.
1. The x coordinate. Now,
yeah.
I keep saying x. I apologize. I'm not trying to confuse you. I meant the t coordinate of the vertex. In other words, this is not an equation in x. It's an equation in t. So our horizontal axis is the t-axis, and the horizontal coordinate of the vertex is minus b over 2a, which is 1. How do I get the y-coordinate of the vertex?
You plug in 1.
For what?
X. Well, t.
Okay. So minus 16 times 1 squared, which is 1, plus 32 times 1, that ends up being 16. So my vertex is what?
It's 1 16.
1 comma 16. In other words, when you write it as a set of xy coordinates, you want to say 1 comma 16. That's a point on that curve, and I can start there. In other words, now if I'm graphing this thing and I don't know anything else, I know where the vertex is. It's at 116 right there. And I know it's an upside down parabola, so it's going to look something like that. I may not have my horizontal intercepts correct, but I got the vertex. The vertex is the most important thing about a parabola. So being able to find the vertex is very important. Let me just do one more of those. I'm going to give you a full equation here. Where's the vertex of this parabola? Where do you start? Always start with the general formula.
Opposite b over 2a, which would be 3 over 2.
Minus b over 2a, which is 3 over 4. Right? In other words, again, don't do it all at once. In fact, the best way to do it is a minus 3 over 2 times 2. That's the best way to do it. And now go from there. In other words, you can't make a mistake if you do it one step at a time. You can make a mistake if you try to figure that out in your head all at once. But when you do it like this, well, the numerator becomes 3, the denominator becomes 4. Okay? So, now, wow, I just looked at the clock. I had no idea we were 15 minutes over. That's what happens when you love teaching math, is you don't care about the clock. But I'm sure you do. So, one last question. How would I get the y-coordinate of this vertex?
You'd plug in what the x coordinate is.
In other words, I plug in 3/4. So it's 2 times 3/4 squared minus 3 times 3/4 plus 7. And now you figure that out however you can. Okay, but doing this step where you actually plug stuff in and write it out before you figure it out, that's a key step. That keeps you from making a lot of mistakes. Okay?
Okay.
All right. Patrick, I will let you go. David?
Oh, he
Okay, that's fine. Good luck on your quiz tomorrow, your final, whatever it is.
Thank you.
I think you're in good shape. I think you know this stuff.
Thanks.
You're welcome. I will probably talk to you in the fall sometime. Okay, all right. Have a good summer. Talk to you later.
Yeah.
Bye-bye.